So today the point of discussion is the Rust programming, and here we gonna implement a matrix multiply on the Rust. So let's get. So what is Rust? Rust is a system programming language which looks like C++ and C, and which is developed and maintained by Mozilla. So the good part of the Rust is it runs blazingly fast, prevents almost all crashes, and eliminates the data races. So the syntax of the Rust looks fairly simple here. So here the main functions, and which is printing hello world. So why Rust is popular amongst developers? So there are four main reasons. First is its reusable code. So Rust allows you to organize code in a way that fosters its reuse. So you can achieve the organization by using modules which contains functions, structures, and even other modules. So second thing is safety checks. Rust compiler enforces memory safety guarantee and other checking that makes the programming safe, which is not provided in C. And so the Rust, you will never have to worry about dangling pointers or using an object after it has been freed. So these things are a part of the core Rust language. Third is the error handling. So Rust provides several functions that are helpful in error handling. And last but not least, the whole assignment is based on concurrency and thread. Rust provide means to spawn threads by using native operating system, but also attempts to mitigate the negative effects of threading. It also includes message passing to allow threads to communicate with one another. So if we compare Rust to other languages, so the biggest vital difference between Rust and C++ is the emphasis on writing the safe code. And safe code meaning objects are managed by programming language from beginning to the end. The developer doesn't do any pointer arithmetic or manage memory as it can be necessary in C and C++ programs. So as you can see here, as the Stack Overflow survey released in 2016 found that Rust to be most loved language among the developers, and the main part of the Rust is its safety and control. Rust is an open source system programming language that mainly focuses on speed, memory, and parallelism. Large and small companies today are using Rust in their production environment. For example, Habitat is using Rust to build command line tools as it is good at compiling for different target systems. As Rust plays well with JavaScript, makes it easy to embed with divided ANS codec in a web page, makes code small, and loads page faster. The concurrent nature of Rust makes sure you don't accidentally share state between threads or tasks. So it empowers every last bit of scaling. As Mozilla is handling millions of WebSocket connections at once during peak hours with Rust servers. Moreover, Rust provides powerful statistical analysis, flexible memory, and fearless concurrency to build embedded devices. So we're going to discuss about memory management now. So Rust gives you the choice of storing data on stack or on the heap and determines at compiling time when memory is no longer needed and can be cleaned up later. This allows efficient usage of memory as well as more performant memory access. Due to this feature, Rust is blazingly fast. Just like C and C++, Rust also gives the programmers fine-grained control on when and how much memory is allocated, allowing the programmer to have a very good idea of exactly how the program will perform every time it is run. So to get the hands-on experience on the Rust programming language, we're gonna implement matrix multiplication both in sequential and parallel manner. So let's get started with the programming here. So here we implement in the fn function in the trait that is implement for both function and closure, which takes the two parameters in the vector and storing a and b, which is same as syntax as a array expression, parsing the argument n as a number of matrix at the time of execution. Next function matrix range, which it generates the thread and seeded by the system using thread range. We are generating uniformly random numbers between 10 and 20 and then asserting these values to the sequential and parallel function. So here I implement the matrix multiplication sequentially and parallelly. Let's talk about sequential implementation first. Sequential multiply a and b takes in two parameters as a vector and store it resultant as a vector. To check that a and b are of the same size, assert equivalent function is used, checking the length of a and b matrix. To reproduce the square matrix multiplication, I loop is transposed with the j loop, iterating for the k loop and storing the resultant vector in C vector. For the parallel implementation, Rayon library is used here. Rayon is a data parallelism library for Rust, and it is extremely lightweighted and makes it easy to convert a sequential computation into parallel one. It also guarantees the data race freedom. So the idea here is to parallelize I loop of the matrix. Therefore, one loop of the section is pulled out here and writing it with the iterator combinators, transposing the outer loop so the resultant vector iterates over the rows of matrix, making it j loop in a separate function. The key to parallelism here is in the I loop by using into par iter function, which takes a normal iterator into a parallel iterator, but it collects the rows as a parallel iteration, therefore it can finish in any order. Therefore, the outer vector is likely to be jumbled up. Par sort by function is used here to sort the vector in the correct manner and storing it into back for loop syntax. Calling that compute matrix combinators Rayon function into the parallel multiply, inputting the parameters of the number of matrix A and B. Running that function gives the execution time optimized by a much more than the sequential implementation. So here we will talk about the advantages of the Rust. So Rust code is fairly easy to read. It doesn't suffer from the hard to parse syntax of the languages like C++ or Scala. It seems to have what I expected to have, and the challenge is just in figuring out which function to call. Second, it doesn't make function programming quite easy as a language like Ruby, but it's close. In fact, it's amazing how easy it is a language that performs comparability to C and C++. Rust forces you to think hard about memory allocation because you have no choice. In the end, it means sloppy code is difficult to write and good code is easy to write. Rust's zero cost abstraction makes it easy to write code without adding overhead. Traits provide modern programming abstraction without performance penalty. And the good part about the Rust is it is easy to parallelize it. There are certain trade-offs the compiler needs to make in order to be able to compile the code within reasonable amount of time. It is reviewed that Rust take longer to compile the code. Being a low-level language, Rust is a very hard to learn. Rust's scope-based memory management makes recursive leak in the memory. It is not the best parallel programming language so far. Low languages like C and C++ gives a high level parallel libraries like MPI and OpenMP, which allows to apply parallel and distributed computing in a wide range of parallel systems. Thank you.